thanks, Alex, for helping me to get here to the HPSF event and present here at the OpenCHAMI User Summit. I appreciate it. My name's Tony James. I'm a chief architect at Red Hat. I've been at Red Hat like 12-ish years, doing all kinds of random things. Most of that involves working with various national labs across the United States, also globally. So yeah, we're here today to talk about bootable containers for HPC use cases, but it is more broadly applicable outside of just HPC. Just by a show of hands, who here has already heard of the open source project bootc? All right, I could just cancel the presentation then. It sounds like everybody. Okay, so you know we'll proceed on, but a lot of this is, I think, going to be just repetitive for some of you who are probably already familiar with the project. It is something that Red Hat is broadly adopting across our portfolio, but again, like all open source projects, it's broadly applicable across non-Red Hat distributions as well. And so why we think containers are the future of not just HPC, but systems in general, it's really these 3 bullet points right here, right? It's widely accepted that containers are portable. Historically, we've looked at containers for packaging up application runtimes, right? Your developers will write some code and they'll ship it to production, and it behaves in production just like it did on their development system. So containers are portable. They're modular. We can layer on top of each different container layer to add on additional capability or change specific functionality within a container image to create various different variants. And then, of course, they're immutable, right? Once you build an image, it's not changing. It's read-only. You'd have to build a new version of that image or a different image if you want something different. And so we call this image mode for Linux. I'll kind of use the terms image mode and package mode. As you see here, package mode is what traditional systems management kind of looks like, where you have a Linux distribution and you use whatever package manager that you're familiar with, apt, yum, DNF, you name it, to install the relevant packages that you want in that distribution, and then you probably use some other tool like Ansible or Puppet or whatever for day 2 configuration management. From a container standpoint, you typically start with some base image, whether it's Alpine, a Red Hat-based variant, a Ubuntu-based variant, or something, and you layer in your whatever applications and libraries and things you need, and you build an image, and boom, there you go. And so what we're talking about is kind of combining these 2 workflows into what we call image mode. So taking the best of building containers with configuration management using packages and turning it into a usable operating system. And we feel that some of the things that image mode helps to fix are revolve around risk, right? So however, outside of this paradigm, however you manage your system images and build those images, what we've seen is a lot of infrastructure ends up having drift, right? Where how do I ensure that every single one of these systems is running exactly the same image, and maybe I didn't miss something. Maybe my automation tool had a hiccup or something, and it missed a few systems, or something got messed up, right? Or something got corrupt on a system. So it helps reduce risk. Additionally, by using containers to build your operating system image, it allows you to take advantage of all the different CI tooling that's been built for building application containers to build your operating system image. And I think that leads to a lot of reproducible builds and a lot more other things that I'll talk about in a later slide. These images allow you to quickly pivot between versions of let's say a standard operating environment or something like that. So maybe in the case of OpenCHAMI, where we are looking to kind of make these systems composable, where one day it might be running as one personality, and then the next day we want it to run as a different personality, right? We're able to do that through switching the image that system booted from. And I'll run through this because I know time is relatively short, but ultimately the workflow looks very similar to what you're already familiar with your standard application-based containers. We're just talking about taking a container image, putting it through a service we call Image Builder, which I know somebody was talking about Image Builder earlier. So copyright infringement, no, I'm just kidding. We put it through a service that we call Image Builder. It takes a configuration toml that you can use to further kind of define some things in the resulting image, and the image that's output can be deployed anywhere. So we support all different kinds of output targets, to include QCal files for KVM, VMDKs, AMIs, VHDs for Azure, ISOs, And we're working on some other things that I think will be highly relevant to this community, such as Pixie images for diskless systems and things like that. So this is the part about the CI that I said I would get to in a minute. With application containers, putting them in a build pipeline, right? You're able to automate a lot of the security-related requirements that you have for like generating SBOMs and scanning for dependencies and out-of-date packages and all those kinds of things. All that same tooling applies here when we talk about putting your actual operating system image build in a container and running it through some kind of automation pipeline. And so here's just a rudimentary example of what a container file could look like to start from this image. So Red Hat, we do provide some bootc base images for RHEL 9 and 10. I don't know if there's one for 8. Yeah, so I don't think RHEL 8 has one. But the CentOS project also has some bootc images that you can start from. Fedora has some as well. I'll be totally upfront with you. bootc, as of right now, as an open source project, primarily targets kind of RHEL-derived operating systems, but there's nothing that says it has to stay that way, right? So if you have a strong opinion about something, pull requests welcome, right? We're always looking to grow communities. That's one of the things about Red Hat. We try to participate in communities that include more than just ourselves, because we want to benefit from that kind of open source development model where we get ideas from all over the place. So we start with an image, and then, you know, this is stuff you should all be familiar with as well, but we can use that image to derive something different from it, and that's what happens. And so when we talk about how we deploy the image to a system, or how we manage what version gets pushed out, or how updates are rolled out, all those kinds of things, it's just like you do your application containers, right? So you probably don't want to have a system running the latest tag, because anytime you change something, that system could potentially get an update that you didn't expect. So using good container hygiene, good container tagging hygiene, using version numbers, production, dev, you know, those kinds of things, that's how we would recommend you apply tagging to your relevant images. And so I'll briefly introduce some of the bootc concepts. So it is a CLI that ends up being installed in the in your booted system. And so bootc upgrade is the command that you would use to pull a new image and you know, upgrade it, stage it for upgrading on the next reboot. Bootc rollback, I'll give anybody $5 if they can guess what it is. Not really. Bootc switch is really cool because it allows you to switch from the I guess the upstream target that you were booted from. So let's say you boot from like a RHEL 10 HPC image that you've built, and you want to switch to a RHEL 10 Kubernetes-based image that you built, right? So it allows you to kind of do that, and it persists the last known image on the disk, so you can kind of A/B switch between the two just by rebooting the host. And then, of course, you can pin versions of it in case you want to maintain a history of images on your disk for further rolling back. And then bootc install would just be to be honest, I don't know why you would use that versus switch, but you could essentially say, hey, I want to install this particular container image on the disk rather than switch to it. And the way it works, I mentioned the A/B model where we persist the last image to the disk so that you can switch just by a simple reboot. You can always run the command bootc status. It'll tell you the particular version that you have installed on the system, as well as all the nice things like checksums and all those kinds of things that that folks are used to. But it does use OS tree under the covers to manage the file system, right? So one thing I didn't mention is these container images, just like application containers, are immutable, right? And so you end up with a system that's booted that has a read-only file system, except for var and etc. And so you can configure OS tree to use composefs as a backend if that's something that you wanted to do. But for those not familiar with it, OS tree it's almost like a Git style hierarchy for your file system tree, right? So it ends up linking the current version of a file to some location on the disk where updates are staged and things like that. So what that enables is delta upgrades. So when you upgrade your file system or your OS image, you don't have to pull down a full new thing just the changes are staged on your disk. Okie dokie. And so I mentioned that we have a base image that you can start from. This is just some statistics about that, just to kind of give you an idea of what it might look like. But it is a very slim, kind of minimal image as a starting point, and then you can layer on from there. We've seen folks do all kinds of creative stuff, like create actual workstation images where they, layer in Wayland and GNOME desktop and all that kind of stuff. In fact, there's a whole open source community, is it Bluefin project? Kush? Yeah, Project Bluefin, where they've built various different desktop distributions based off of Fedora for like KDE, GNOME, all those kinds of things, using bootc and these containerized operating system delivery mechanisms. And so, those are all the slides. I went really fast because I figured there were going to be some questions, and I didn't want to bore you guys to death. Okay.
So, how would I use this for the initial boot of the system? Because I can understand the upgrade path, but I don't know how you get there to begin with. Can I iPixie into bootc, or how does that work?
Yeah, so I mentioned we are working on Pixie support for bootc so that you can, handle those diskless use cases and all those kinds of things. What you would do today would require a disk in the node or some install target, maybe it's a LUN or something like that. You can start from a kickstart file, and there's a line you add in your kickstart file. It's like OSTree commit or something like that, and you point it to the container image, and it writes it out on the disk.
And then our typical way of handling ephemeral stuff like we're putting in bar and Etsy, we put that on an overlay FS that lives in RAM. There's nothing that would prevent that from working, I guess, right?
I don't know for sure. I do know that there is some way to create like a temporary overlay that's writable, but it won't persist over reboots. So yeah. Yeah.
So you mentioned you have some like bootc base images.
Yep.
If you were going to create one yourself, like for example an Ubuntu based image, what has to be in that? Is there a recipe?
That's out of my scope. I don't know. Again, right? The community is moving forward with like rel-based distributions, right? So Fedora, potentially Rocky, Alma, those distributions. Given that it does have a dependency on OSTree, I think that's going to be where a lot of the showstopper ends up being, right? Because OSTree has a layer called RPM OSTree, which relies on RPM based packages and things. So you'd kind of need to peel apart the various different dependencies and figure out how to make them fit in an alternate distribution. But Colin Walters, who is the guy who built bootc, he's very open to feedback, and he's very active in the community. So much so that I tried to schedule an internal meeting with him one time, and he was like, "I'm not joining that. Just ping me on GitHub, and we'll talk in the open for everybody to see." So.
You also mentioned your image builder.
Yes.
And you might want to repeat the question for the microphone.
Yes.
But so is the image builder then something that is currently open source that we should be using instead of the one that we trademark infringed?
So the question was, should they be using the image builder that we provide versus something that they've created themselves? Potentially, right? I mean, duplication of effort is not always a good thing. There's going to have to be some kind of investigation to determine, does the image builder that we deliver meet your requirements versus you having to layer on additional capabilities, or could you just extend what we're doing? The tool is actually called bootc image builder, and we distributed it as a container image, so when you go to run it, right, it can be run on any system. In fact, for those who have used Podman Desktop, which is a tool you can download on your local workstation, we provide an extension to Podman Desktop that will run the bootc image builder for you in Podman Desktop, so that way you can just build your images right there on your local machine.
So I was actually looking at the bootc image builder. I didn't really find a lot of documentation about how to actually use it to build an image. Is there extensive documentation somewhere that tells you how to actually do that?
Yeah. So, surprise, open source communities aren't always diligent in their documentation practices, right? But what I would do is point you to docs.redhat.com, specifically the rel 10 documentation, and there's a whole guide on building images with bootc. And I can, send you the link if you want to ping me. My email address was in the slides.
Thank you for presentation. I know waiting assist backed by RPM OS3, but I didn't know bootc. What's the difference between bootc based waiting assist and RPM OS3 based waiting system?
So the question was, what are the differences between RPM-OS3 and bootc? Correct? Yeah. So we had a variant of RHEL previously called RHEL Atomic that was just, it was immutable. It used RPM-OS3, but it wasn't built from a container image, right? It was more just OS3 commits. I mentioned OS3 similar to like a Git file system, if you will. And that worked well for, various different use cases, but then this idea of like, hey, we use containers for applications and all their dependencies. What if we shoved a kernel in there and all the relevant things to build a full system image? And what would that look like, right? And so that's really what bootc does. It recognizes the fact that you have a kernel, and this is designed to be a full system image rather than just an application image. And it has some logic to tie into the bootloader, to tell the bootloader how to boot this image and all those kinds of things. So that's really where some of the differences come in, right? It extends RPM-OS3, which is just the file system, to handle the full system kind of provisioning logic. Yeah.
Does the image builder do anything to take into account when you're doing cross-compile, building ARM images on x86 or vice versa?
Not today. So right now, the bootc image builder, like I said, it's distributed as a container image. It's very like the architecture that you're running it on is the architecture that the resulting image is going to be built on. We are looking to integrate it into our, if you've ever been to like console.redhat.com, we have an image building service up there. It's kind of like graphically driven. So we are looking at ways to integrate it there so that you could say, just give me an ARM image, give me an x86 image, whatever. There is also a local variant of that. It's built on, it's an extension to the Cockpit project, which is a web console for systems management. It's called Composer. And so we're looking at ways to integrate it there too for those disconnected environments where you need to build images locally.
So, when you say image builder, is it taking a container, like an OCI artifact, and turning it into like different, like a list of things you can specify?
Yeah. Let me see if I can VPN into my house real quick. Stop mirroring. Choose. All right. Who here runs Unify hardware at home? Anyone? So Unify has this handy little feature called Teleport that allows my laptop to teleport its network connection back to my house, which is kind of cool. But the reason I want to do that is because I have a system in my lab that I can show you the bootc image builder stuff. I just, for whatever reason, it doesn't push the DNS entries. All right, so I need to go here. Oh my goodness.